We are going to take a look in our next unit, Unit 2. We're going to be talking about transformations, especially in the coordinate plane. And so we're going to look at some specific ones today. In Unit 2, Day 1, or Day 2.1, is over reflections. All right, and then you'll see on your second page, okay, so make sure we get these in the right spot. Don't write the wrong thing in these blanks. The first page you got in class says the word transformation here and reflection underneath it. Okay, so that second page over translations is still part of Day 2.1. And then we're going to take a look at these two specific kinds of transformations. And transformations in geometry is where we take one figure. It's an operation that we use the word maps an original figure that we call the pre-image. And it moves it or changes it into some way so that we get a new figure that we call the image. And we will use this phrase mapping or maps to describe what we are doing. Now, a transformation could change the size, position, or even the shape of an original figure. Okay? So we're going to look at one major reflection today. There's four main transformations we're going to look at. The first one is called a reflection. And a reflection, in general terms, is a flip over a line that is called the line of reflection. In a reflection, each point and its image are the same distance from that line of reflection. So if we look at this, we've used some notation here. This is what we would call our pre-image. And then the result over here on the right is what we would call the image. Pre comes first, pre meaning before. So before the reflection, our triangle starts out here, and then after I reflect it, I get this one. And you'll notice after each of these letters is a little apostrophe. It's kind of hard to see, but that's what that is. That would be A with an apostrophe after it, B with an apostrophe, and C with an apostrophe after it. And those are called prime notation. And we're going to take a look at what that means here in just a minute, but that's prime notation. Okay? And so we would consider that B is reflected into B prime. That's how we would read that. Okay? B is reflected onto B prime. A is reflected onto A prime. C is reflected onto C prime. Now, we could reflect over any axis, but there's some main ones that we will use in the coordinate plane. We could use the x-axis. Okay, that's the horizontal axis. I'll just use this as an example. That's your x-axis. That could be the line of reflection. Or even the y-axis. We could even use any other vertical or horizontal line in this form. A vertical line is always in the form x equals some constant number, pound sign for number, or hashtag meaning number. All right, this is always a vertical line. Okay? Or y equals a constant number, which would be a horizontal line. We'll look at reflections across those kinds of lines other than just the axes. Okay, here's your y-axis. But we can also reflect over diagonal lines. And the two that we will use, even though we could use any diagonal line, we're only going to use the line y equals x or y equals negative x. Those are the only diagonal lines we will use for reflections. So we're going to do some examples here. We're not going to cover all of these examples in this practice session. We will do some of those in class, but we are going to do an example or two and do some more examples together when you come back. So here's what we're going to do to start. The first thing we want to do, even before I read really any of the rest of this, is I want to plot the original points and make this triangle ABC. This would be my pre-image, my original figure. Okay, so I want you to plot those points. Remember, the x-coordinate comes first, y-coordinate comes second. And this is what you should get when you plot these points. Okay, and we want to reflect that figure across the x-axis. So I'm going to trace that axis for you so we know which one we're dealing with. We're using the x-axis here as our line of reflection. Well, the easiest way to do this, and we're going to use some other forms to figure out how to do this, but a reflection across that axis is very, very easy. We are just going to reflect by remembering that every corresponding new point, A prime, B prime, and C prime, will be the exact same distance from the x-axis. And so all we're really doing here to reflect across the x-axis, I'm going to move C because it's closest. I'm just going to start with that. I'm going to move C one below the x-axis. I'll change my color a little bit. Okay, C is going to come down here. So it's not moving left or right. We're just reflecting it straight down across the x-axis, and that becomes C prime. Then I'm going to move kind of just around to A. It's a little closer, or a little further from the line, but still not as far away as B. And A is 2 directly above that line, so I'm going to move A 2 directly below that line to get A prime. I'm creating a reflection, like a mirror image. Like this line is my mirror, and the rest of this is exactly the same distance away from it. And then B prime, if you'll count directly up, 1, 2, 3, 4, 5, 6, 7. It's 7 above the x-axis, so I'm going to move it 7 below the x-axis. 1, 2, 3, 4, 5, 6, 7. You'll notice B is still lined up vertically with B prime. C prime is lined up with C, and A prime is lined up with A. Then I'm going to connect those, and it looks like a perfect reflection of my other triangle. But then I always want to make sure I finish by actually writing these new coordinates in. Okay, so we'll start with A prime. A prime has the coordinates -4, -2. B prime has the coordinates 4, -7. And C prime has the coordinates 5, -1. Now I want you to look at how these coordinates relate to the original coordinates. And you'll notice that the x values are not changing. For A, that x-coordinate is -4, and A prime's x-coordinate is -4. So I'm not moving left and right. The x values stay the same. B stays at 4 for its x value, and C stays at 5 for its x value. And so we're going to teach you how to write these in mapping form. And here's how we write a mapping rule. Mapping rule. We start with an ordered pair x comma y, and then we draw this arrow into our new ordered pair. Now x does not change, so we would read this as x maps to x, but y does change. Look at how the y values change. We go from a 2 to a -2, a 7 to a -7, a 1 to a -1. Well, in that case, we're taking the opposite of our y value. We're just taking the opposite of each of these numbers. If it started off as a positive, it changes to a negative. So we say that xy maps onto x -y. Okay, we're going to try one more example. We're actually going to skip down to number 3, and we're going to try and reflect that across the y-axis, but we're doing a trapezoid this time. We still want to start with drawing our 4 vertices from our original figure, and we should get this. Okay? And we're going to reflect this trapezoid across the y-axis. So I'm going to trace that line, and we're just going to move everything across the y-axis. Well, since h is already on the y-axis, h prime is going to stay exactly there. It's moving 0 away from the y-axis. We're not changing that at all. And so that one I can go ahead and fill in. H prime and h have the exact same coordinates, 0, -6. But the rest of these are going to move, so we'll look at G. G is 2 to the left of the axis, so we're going to move it 2 to the right of the axis for G prime. F is 5 away from that axis, so we're going to move it 5 on the other side, or we can think of counting from G prime like we counted from G. F is 3 units away from G, so F prime will be 3 units on the other side of G prime. Okay, I is 8 units away from that axis, so we're going to go 8 on the other side. There's I prime. And so we get our reflected trapezoid here. And we just want to write those coordinates in. When we identify these ordered pairs, we should get this. And you'll notice when we get these ordered pairs and I compare them back to the original ordered pair, the y values this time have stayed the same. -2, -2, -2, -2, -6, -6, -6, -6. So the y values are not changing in my reflection, but the x values are now their opposite values. So our mapping rule might look like this. xy maps into or maps onto -x, y, because we have the opposite x value. Okay, we're going to do some more examples with reflections because there's a lot of different reflections we can do, a lot of different rules we can figure out later on. But right now, we are going to go ahead and move to the second page of notes and talk about translations. Now, this is not the same as the word transformation. Translation is a specific kind of transformation, which we're going to talk about now. If at any point you need to pause the video, make sure you do so and get this all copied down. Okay, so we're going to take a look at a translation which is to vertically and or horizontally, so it might require both, but it's a slide of a figure. Okay, we're going to move it without turning or reflecting at all. Okay, we're not flipping it, we're not turning it, we are just sliding it like along a pathway. But every pathway can be described in its terms of vertical and horizontal changes. So the symbolic form, or our mapping rule, looks like this. We start with an XY ordered pair, and we are going to translate it using a specific set of rules. Now, because we are moving horizontally and vertically, that means we are adding or subtracting from X and Y. So we're going to write it like this: X plus H, comma, Y plus K. Okay? Now here's what these represent. This H value here represents the horizontal shift. And the K value, what we add to the Y value, represents the vertical shift. Okay? So all we're really doing here are taking our ordered pairs and moving them this way. So here's one way we could work on a translation problem. We want to start by plotting the original coordinates. So pause the video and try that yourself, but I'm going to show you what we should get. We're going to move this following this mapping rule. Now, if I'm adding 5 to my x values, on the x-axis, when I add, that moves me to the right. So I should remember that this is going to move to the right, 5, and then adding to the y values moves it up, 7 in this case, because it's adding 7. So what I could do is I could actually take each of these and just kind of do a little triangle, over 5, up 7, kind of like we did slope calculations back in Algebra 1. Or I can actually take the numbers given and get my new coordinates first and then plot them. And that's what I'm going to do here. So Q, I'm going to take -6 and add 5 to it. -6 plus 5 is -1. And I'm going to take my -1 y value and add 7 to it. -1 plus 7 is 6. And I'm going to keep doing that. R, I'm going to take the x value, -3, and add 5, which gives me 2. And then 1 and add 7, that gives me 8. I'm going to go to S now. 1 plus 5 is 6 for the x coordinate of S prime. And -5 plus 7 is +2 for the y coordinate of S prime. Then T prime has the coordinates -2 plus 5 is 3. And -7 plus 7 is 0. So we're going to calculate those. If you need any help on how I got these numbers, make sure you ask me in class, but we're just adding 5 to every x and adding 7 to every y for this rule. And you'll see that moves it to the right and up. So negative 1, 6 is now here. That's q prime. 2, 8 is now here. That's s prime. Sorry, r prime. And 6, 2 is s prime. And 3, 0 is t prime. So I still have the same rectangular shape. The letters are still in the same order. It's just now they are the image after this translation. Okay, so we're going to try one more in this video, and then we will do the rest, or some more of these at least, in class. Okay, I want you to try number 2 and follow this rule. And here's actually what we're going to do. I'm going to have you try and do this one on your own, and then when you are ready, push play, and you will see if it matches what I got. Okay, here's what this should look like. Hopefully you have enough time to do this. If not, pause the video again now to make sure you're getting this done. All right, we see our original figure here, triangle CDE, with these vertices given to me here. And what I'm going to do is to each of those ordered pairs, I'm going to take the x value and subtract 3, and the y value and add 8. That means I'm going to move to the left 3 units and up 8 for the y values. And so when I do that, I get these new coordinates. And when I plot them, it does show me that I've gone to the left 3 and up 8 for each one. Okay, so we'll take a look at more translations and reflections in class, but this concludes your video notes for Unit 2, Day 1.